guys, here is the review for the test we will have tomorrow. Write a linear equation for a curved line that passes through the points of the arithmetic sequence given below. So even though that says curve right there, it just means line. Okay, so any line can be a curve that passes through the points of the arithmetic sequence given below, right? So I've kind of already started a table where we have our u value and our u sub n value, which is the outputs, our input and our output. So the first one, if I input 0, our output is 7. That's from right here. Our first term is 7, right? And then it says what's happening every time. In order to get the next number, I don't know why I'm struggling here today. In order to get the next number, I take the previous number and I subtract 8, right? So if in order to get the next number, it would be 1, and I subtract 8, that would give me negative 1. So what you could do is you could use this as 2 points and find the slope and then write your equation. But I think we have enough to write an equation in slope-intercept form. We have the slope, right? Our slope is negative 8. And we have the intercept, which is our first term where x is 0. And that is, we usually call that b, I think, in your notes. And that is 7. So our equation in slope-intercept form could be y equals negative 8x plus 7. Okay, so what this question wanted you to do is it wanted you to use your knowledge of recursive sequences that we had last unit and take it to the next level and see if you could turn it into just a linear relationship. Okay, and our favorite, solving systems of equations. On the test, it will tell you if it will allow you to use the calculator or not. If not, it will say something like show all of your steps algebraically or whatever, I think is how it says it. So if it says that, you can definitely check using your calculator, but you're going to have to show all your steps. So 4u plus 3v plus 2y, so 4u plus 3v plus 2y equals 44. And it looks like this is going to be kind of an easier one. 3u plus 4v is 36. 3u plus 4v is 36. And 3u equals 12. Oh, look at this. You guys want to see something really cool? Look at this one. This says 3u. This says 3u. I can already solve for v by doing this. Look, instead of 3u, I'm going to put 12, right? Because that's what 3u is, plus 4v equals 36. So subtract 12 from each side. 4v equals 24. Divide both sides by 4. V equals 6. Okay. And u equals what? 12, because 3 times 4 is 12. So u equals 12. V equals 6. Now we'll go back and put them in to solve for y. Let me erase some of this stuff over here. Okay. And back here, let's see. I like to use this thicker one. I don't know why, you guys. Okay. So 4 times u, but instead of u, I'm going to do 12. Why did you let me write that down? It's obviously 4 over here, right? So 4 times 4 plus 3 times 6 plus 2y equals 44. 4 times 4 is 16 plus 18 plus 2y equals 44. I'm tempted to let you guys just finish this, but I might as well. 16 and 18, 6 and 8 is what? Let me count in my head. 8, 9, 10, 11, 12, 13, 14. Carrier 1, so 34. Okay. 34 plus 2y. You guys might want to double check my mental math on your side. Subtract 34 from each side, you get 2y equals 10, and y is 5. So u equals 4, v equals 6, and y equals 5. Cool. Double check with your calculator, right into the matrix 3 times. The second time you're looking for the RREF, right? And then you just put in whatever matrix you use, like if you used A, and it should help you out there. Let's see, what's next? Whoops, too far. Woo, choose the most appropriate model for this data. Okay, and then I have on there that I want to use a linear relationship. So let's start thinking about what we're going to need for a linear relationship. So let's go ahead, and I'm going to put this table somewhere else where we can see it better. Cool. So a linear relationship for this, and since I have, what am I given here? I am given points, right? This table is basically just a bunch of points. And what's happening here, your latitude and your temperature. So the farther north or the farther south you're going to get, probably your temperature is going to be lower, and right in the middle it's going to be higher, right? So we're given points, and we can use those points to find a slope, right? So we're given points, we can use those points to find a slope. So I'm going to use the form of a linear equation called point slope form, right? Okay, now let's get rid of some of the stuff so we have more room to work. So point slope form, let's find the slope first. The slope is equal to y2 minus y1 over x2 minus x1. So let's just choose 2 points to use. How about London and Cairo? London and Cairo sounds pretty cool. So I would like, well, I used to live in London, but I definitely like to visit Cairo. So our temperature is our y. And it doesn't matter which one you say is y1 and which one you say is y2. It's just that if I use, like, let's say I use for y2 51.8, then I have to put the corresponding x directly underneath it, which is 51.5 minus 71.4, and then down here that's going to be 30.1. Okay, see, it's warmer below. Okay, so this is going to give us a negative slope, I think, yeah? So because 51.8 minus 71.4, let me get my calculator here. I definitely don't want to mess that up for you guys. Cool. Okay, so 51.8 minus 71. You guys are probably already done by now. 0.4. I forgot my point. Oh my goodness. I think I can just move the decimal one place there. Let's just go back and enter that point in. So it should be 44.66, but just to be on the safe side, let's second insert a decimal. The 1 point. Okay, there we go. negative 19.6. Oh, so I was wrong anyway. See, good thing I didn't do that. Negative 19.6. So I have negative 19.6 on the numerator, and on the denominator I have 51.5 minus, I can do this in my head, that's going to be 4.4, and then 1 minus 1, and then cool. So my slope's going to be negative, but I'm going to do that division in the calculator. So I have 19.5 minus, I hope you're listening to this too, or else, oops, divided by, you might not be able to read my handwriting there, 21.4. Okay, and it is negative. I didn't put the negative there, but it's not going to change my answer. Negative 0.91. I'm just going to do that, and I'm going to make these an approximately sign. So there's my slope. I'll write it. Here, let's do this. Let's say that my slope is approximately negative 0.91. And then we can erase all of this. Happy numbers, happy numbers. And then let's use one of the points, and we'll just put it in to point slope form. So y equals my slope, negative 0.9 times x minus, let's do Cairo, 30.1. Okay. And then plus 71.4. Okay, if you are not remembering this, you need to look back in your notes for all the different types of forms of linear equations. And we've used two so far. We used slope-intercept form just before this, and then we used point-slope form here. What was the other one we use mostly for elimination is the standard or general form. Okay? Okay, what's this next one? This next one says use an algebraic method to determine the value of the following systems of and in, that's weird, the following systems of equations. So look at this. It's all set up to use an algebraic method means for sure that you're going to have to show your work, okay? An algebraic method means for sure you're going to have to show your work. So we could do elimination or we could do substitution. If we did, I might need a finer point for this one. If we did elimination, I would multiply this top equation. I think I want to do it by negative 2, and that should cancel out my v's, right? So I get negative 12u, you have to multiply it by every single term in there, minus 2v, v equals negative 36, okay? And then we keep the equation below the same, 5u plus 2v equals 22. Then I can combine them, and negative 7u, and then the v's cancel, equals negative 14. Oh, that makes sense because negative 7 times 2 equals negative 14. So my u is 2. Huh. U is 2. Okay, so now I just need to find v. I need a little more space here. Cool. I need to find v, so now I can go back into one of my original equations, and doesn't matter which one, I'll just do the top one. I have 6 times 2 plus v equals 18. 6 times 2 is 12, plus v is 18. All I have to do is subtract 12 from each side, and I get v is equal to 6. Yeah? I think think so. So U equals 2 and V equals 6, and I did this using elimination because they were in standard form, so that was the easiest for me to do. What's next? Whoops, gone away. Matt and Ming are selling fruit for the school fundraiser. Customers can buy small boxes of oranges and large boxes of oranges. Matt sold 3 small boxes of oranges, means 11 small boxes of oranges, 11 large boxes of Find the cost of each one small box of oranges and 1 large box of oranges. And I have you graphing both of these because there are questions on the test that are going to have you graphing things. So let me see if I can get a, let's see if we can copy this in somewhere into the other one so that I have all of this information. Oh, cool. You guys, look, I am so technologically savvy. You are so lucky to have me as a teacher. Okay. And why don't we make our equations first and then we can graph them? Does that sound like a good idea? And usually with these, if we're talking about systems of equations, it's easiest to write it as a standard or general form, but let's see how this turns out. Matt sold 3 boxes of oranges, 14 large boxes of oranges. Okay, so we have S. I have to define my variables, you guys. X equals small box. Okay, and L equals large box. Okay, so if we have 3 small boxes, Matt says 3 small boxes and means plus, and 14 large boxes, he made $203. See, so it's $3 for each small, oh, I'm sorry, here, S is like, it's a small box, but it's actually the dollars. Okay, these are both money and dollars, because if we have 3 boxes, we have to multiply it by a certain amount of dollars because our output is in dollars. It doesn't matter by looking at it, but just so you know what's going on. Ming sold 11 small boxes, okay, of oranges, and that means plus 11 large boxes for a total of 220. Okay, so you choose a way you would like to solve this one. I mean, elimination is always nice here, although in this case you would have to multiply both the equations by a number to get something to cancel out. Why don't we practice on the calculator? Let's go ahead and go into the matrix. Okay, edit, I'll use matrix A. And this is just, we have 2 equations, right? So it's a 2 by 3, right? We have 2 rows and 3 columns, okay? So now I can enter in the coefficient. So I have like 3, I'm going to enter in 3, 14, and then 203, and then 11, and without the variables, right? 11, 220. So let's say 3, 14, 203, then 11, and these are all positive numbers, 11, 220. Okay, and then you have to quit out of here, right? And then we go back into the matrix, and then we do math, and we are all the way down to B, which is RREF. Woo! RREF. And then I put this into matrix A, so I go back into the matrix, I select A, right, enter. Cool. So here the first column is S, right? So that's small boxes. So if you look over here, right, I have 1 in the first column, so it means 7. So one small box is $7 and one large box is $13, right? So a small box costs 7 and a large box costs $13. Okay, so what do we mean by graph this? What do we mean by graph this? And it's not going to make a lot of sense in terms of this problem because we don't have an independent and a dependent variable. Both variables are just different sizes of boxes. But what we're going to do is change these equations around and just solve for one of the variables in each one. So if we want to solve both for small boxes, we have 3s plus 14. We want to get the s by itself. L equals 203. So we subtract 14 l's from both sides. So then we have 3s equals 203 minus 14l, and divide both sides by 3. And you have s equals 203 divided by 3. Let's see, 203 divided by 3. 67 2/3. And 2/3. And then we have, oh, where did my L go? Oh, here it is. It just looks like a 1L minus 14 over 3L. So that's my slope. Down 14 over 3, right? So let's write this over here. S equals 67, and I'll just do 0.67 minus 14/3 L. Okay, and then we need the other one, so let's make some room. The other equation, I can already, no! The other equation I can already tell is going to have a slope of 1. Can you guess why I said that already? If you can guess why, your understanding of manipulating equations is really good. So this time we're solving the bottom equation for s. We have to solve them both for s. So I'm going to subtract 11 l's from each side. Okay, so I have 11s equals 220 minus 11l, then divide both sides by 11. And what that means is that s, sorry you guys, let's delete that. S is equal to 220 divided by 11. Let's see, 220 divided by 11. 20. That went in exactly. This is going to be such a nicer equation. 20 minus 11 divided by 11 is 1. So just minus L. So that slope is just -1. So here we have S equals 67.67. Oh, son of a gun. That's not what I meant to write, right? That's the one above it. S equals 20 minus L. Okay, so now we have the two equations we're going to graph. Okay, to make this a little bit easier, we're just going to sketch this, and then we'll just put the important parts down on it. So we'll do it on the calculator, we'll sketch it, we'll put the important parts down on the graph. You can do the same thing on the test. So let's pull up our calculadora here, and whoops. Let's pull it over here so I can see the equations. Cool. So we put these equations in the y equals. So the first one is going to be So, oh, you know what? And then you guys, I'm just going to put into the first one 203 divided by 203 divided by 3 here, because that's going to be what gave us 67.67. And that way the calculator gives us an exact answer. So I'll just do 203 divided by 3 minus, and then in parentheses again, 14 divided by 3 times x. And in this case, the x is the L, right? And then the other equation, we're going to do just 20 minus x. Okay, and let's make a good window. We're not going to have any, or we don't care about any negative numbers, but let's make, if I don't have negative numbers, I still like to do -10 as the smallest so I can see the axis. And then how far does my x go at my large box? The answers were 7 and 13, so let's just go up to 20. I bet that'll give us a good one. And then we're counting by ones. That's what that x scale there means. Then let's do y minimum. We can do -10 also. Actually, let's make that -2, because if we're not going very high, this will give us a better one, a better view. And then how high does my s go? It only goes up to 7, but let's go ahead. Let's just do 20 for that one too. And then count by ones. Cool, let's see how this works. And actually, I'm going to turn off my stat plot because I know I have one on, and I don't want those dots to get into the middle of my graph, so I'm going to turn that off. Then go back, and since I fixed the window, I should just be able to hit graph. Cool. Look, you guys, and there's my answer. And actually, I want both of those y-intercepts. So I'm going to go back because I want that. I'm going to go back to my window, and I know one of them hits the x-axis not until 70. So my x is, I'm going to take my x up to 80, and then I'm going to count by 5. And let's see what that looks like. Or my y, I'm sorry, my y up. Because now I can see the both of the y-intercepts. Because when we sketch it, all I'm going to ask you to do is show me where the y-intercept is and show me where they hit, okay? So in order to find the intersection, this is fun, we just do, and I mean, it's going to, obviously, the intersection is going to be 13,7, because that's the answer we got. But if you want to double check on your calculator using this graphing method, you can do second calc. We want to find the intersection, so I'm going to hit 5. And it says, is this the first curve? And I hit enter for yes. And it says, is this the second curve? And by curve, it means line, and it is, so I hit enter. And do we want it to guess at an answer? Yeah, we do. Okay, and when it says intersection, that's how we're going to know. And it's 13. Remember, we made the L's kind of the X's 13.7, so we were correct. So let me just show you how we can graph that really quick. We're just going to make our axes. And when I say sketch, oh, that's terrible. I need to practice this. Oh, no. You guys. I'm so sorry, this is going to look terrible, but let's just do this. I'm so sorry that it looks terrible. There must be a way to get a straight line in there, but I don't have time to do that right now. So I need a couple of points. I need this. This is going to be approximately 67.6, right? The y-intercept for that one. And the y-intercept for this one was just 20. Right? And I'm sketching it, so I don't have to have a good scale or anything. I'm just sketching it. And then this one comes down like this, and this one comes down like that. And then this is where they cross, where our large box is down here, right? So that's the point 13. And this is our small box on the y side. And that was 7. So they cross right here. The point is 13, comma, 7. And this could be the relationship between large and small boxes. I love to have my graph titles as the relationship between. So the relationship between large, small boxes of oranges. The bell's about to ring and interrupt me, which is why I'm hurrying here. And that's a good sketch of this graph, right? This is the x-axis, this is the y-axis, this is our answer. They both have negative slopes. Please watch this. Please come with questions. We'll go over stuff before we take the test tomorrow. I hope you have a good night.